Hello everyone. So, what I'm going to show you here is what we call silicon casting. Silicon casting is something, I'll be honest, I'm kind of new to as well. Like, I've only just been messing around with it recently, but it's actually really cool. You can basically take any 3D printed model that you have, and then you can make a mold around that. And then after that, because silicon has such a high temperature tolerance, you can then basically pour in, I don't know, not literally any material, but like you can pour in a lot of different materials. For example, like you can get resins which come in 2 parts, which can be dyed and colored. So you can get this stuff here called, casting resin. It's the wrong way around for you. Casting resin is made up of 2 parts. You've got the actual resin, and then you've got this little one here, which is the hardener. And so you have to get the ratio right. When you're mixing it, you can add dyes in as well to color it, and then the results can actually be pretty cool. I mean, you can see here's a mold a student made. It's a silicon mold, and we've got some other examples here as well of, here is actually a resin, this is actually a resin cast a student made. And so they had the silicon mold, and then they cast this around it, which came out actually really well. And you can see here one of the formers for that part. Ah, here it is. That was it. I was just looking in the wrong place. Yeah, so that's the inside of the part, and silicon part, and then you can see here that the resin would fit over the top of it just really perfectly like that. And then the other half of the mold looks like this, and it's got the negative side, or the cavity as we call it, and then that would fit over the top. And then we've got left a hole here, and that's called the sprue. We can pour the resin in. There's little air holes around the side to let the air out, and then that will fill the mold up. And basically the reason we do this is because it resembles injection molding. It enables us to actually cast proper parts out of basically materials that resemble plastic. And you can see here, here's another part the student made, which is the negative of a case part for an electronic product. But yeah, they come out really, really well. Like, the silicon will take on an exact replication of whatever the 3D printed model is. So I'm pretty excited because I've got here, this is a little sample I've made to show you. Really easy to make this. Silicon, luckily, is pretty straightforward to work with. You have 2 tubs. You have, similar to the resin actually, you have the actual silicon rubber, and then you have the, basically the chemical which sort of cures it and sets it. And you just mix them literally it's equal ratios. And yeah, and it will set in about 4 hours. And then you get literally like solid, well, it's not solid, but it's set silicon rubber. Now, what is so good about silicon is that nothing can stick to it. It's this really remarkable material where no adhesive, no material will stick to it. And that's why it works so well for making molds, because you can use even this, like cardboard I've used here. This is just a cardboard tube, and I've got my 3D printed former inside here. And yeah, it's brilliant because nothing can stick to it. So you can see here already, that's peeling away nicely from the cardboard. So what I'm going to do is I'm just going to cut around. This is like, it's kind of like, if this was a metal, we'd call this bit flashing. Just going to peel away the flashing around the edge of the 3D printed former here. And this is so that when we actually then pour the material later, because I could even try pouring in like a low melting point metal like pewter or something into here and see what happens. Yeah, and it's just a really, really useful process, because with this we've got a mold. And when you've got a mold, you've got the ability to replicate. So we could cast one, and then we can cast another one, and then this mold will last for ages. Like, we'll be able to do multiple casts out of one silicon mold, and that's why it's so good. So if you're doing like batch production of something, this is ideal. Okay, I'm going to take the silicon out of the cardboard tube first. See if we can do this without having to cut the, here we go, perfect. So you can see that's just starting to come out there. Just a little bit of flashing on the top there is just holding it onto the cardboard tube a little bit. But you can see just how flexible silicon rubber actually is. And, oh, there we go. You can see that cardboard tube is also still intact. That could be used again. yeah, to make a sort of housing for it. Now, I actually made this with some excess silicone I had left over because I had it in a bucket and I didn't want to waste it. So I thought, right, well, I've got this 3D printed former. Let's just make a mold. And I have no idea how it's going to turn out. But I found this cardboard tube and I literally just put it on a bed of scrap acrylic. And yeah, and I just poured the silicone in. So here we go. This is how it works. We've got the 3D printed form. Come on then. The only trouble with this is actually quite a difficult cast to make because it's a very intricate logo actually on the other side. I was thinking about trying to make a sort of like a little stamp, and this could be the downfall of this kind of design, is because it's so detailed. Luckily, silicone has a very high elastic limit. So there's the former. See, it's in reverse. Well, actually, no, it's not in reverse for you, but it is for me. And that has come out okay, not bad at all. You can see there it's taken on the perfect reflection of the material. Now, that means I could give I could give this a go with casting some metal in. Now, there's going to be a few issues with this. Really, if that was going to work properly, I'd need to have air holes coming out the other side, but we'll see how it goes. So that I can just literally leave on the table like that. I can pour the resin in, leave that to set for however many hours, and then, yeah, and it should be good. Sometimes when people cast, they'll put in this, they'll spray it with some of this, which is silicone release agent. So they'll spray the former first, or they'll spray the mold first. And all that does, it just puts a very, very thin film. It's a little bit like WD-40. It just enables the silicone or the part to just release more easily. Okay, so there you go. That is basically, yeah, almost like injection molding, but not quite. Silicone casting is what we can